One second. All right, today we're going to talk about our office and some practical workflows and how we integrate using FormIt in the early concept and design stages, and really trying to focus on how you can utilize tools to enable the integrity and continuity of intellectual information throughout the design process with the rest of the team. So how to use some of these tools early on and get the most impact and the greatest sort of transfer of information through the design process. We're going to take a look at a couple different projects, how we start them in FormIt. I'll talk about why. It sounds if there's any BIM managers on the line, I apologize in advance because I'm going to be talking about why you should start the project in FormIt and not necessarily in your Revit model. We're going to show some ideas about site analysis. I'm going to talk about some of those workflows with FormIt, with some other mobile applications that I use, one being Sketchbook Pro, how we use Autodesk 360 and communicate with the team through that service. And I'm going to talk a little bit about in detail a workflow about how we can get some topography, which is built as topography, into the FormIt model. Some of the work I'm going to show is nonlinear in nature, and I'm going to move around a little bit. And what you'll also see is some of the artifacts, some of the things that I'll be showing. As Tom said, we've been working together for about a year, a little over a year, and so some of the things that have been created were in much earlier versions of the software itself, and the software has evolved and continues to evolve with input from people who are using it back to Autodesk. Just a little bit about myself. I'm the principal and practice leader for Array Architects. We're just over 100 people in we're 8 locations, which you see up on the map on the screen. And I'm going to talk about a little bit how we work. We work through those offices. Obviously, we have different amounts of staff in each office, and our leadership is distributed. We also engage in projects across multiple offices. So my teams at times may be distributed. The work may be distributed to where the expertise and the leadership of that work is throughout those offices, and we work virtually. We work across a VMware product to have the teams access things like the production model and our servers. Now, because our leadership is distributed, planning, interiors, and design, it's often the red dot in the middle, which is the person, that may be a thought leader on a project, responsible for certain aspects of it, and they might not be necessarily located in the location where the projects are taking place. So we started to work through a series of what I call mobile work style, like where you're never really in one place and you're always over a Wi-Fi someplace on your laptop or your iPad, and how mobile design applications can help support that mobile work style. So, for example, I try to focus on using my iPad. There's a series of apps that I use, one being FormIt, which is I use pretty intensely. I use that in combination with Sketchbook Pro to help communicate ideas. I use Autodesk 360 to save files and connect information with my teams, and I use a host of other applications, Google Earth, Street View, Maps, PDF editors, my camera, Sketch, which is the pink one with the arrow with the feather on the bottom, which I use to mark up and annotate things at times, and Photoshop from time to time. So the result of that is, a series of images that I effectively will have on my iPad or working documents that I can kind of move back and forth to help communicate with my team, and I'm going to walk everybody through a little bit of that right now. First thing I'd like to talk about is starting the project off in FormIt. Might seem a little counterintuitive because it does not necessarily have all your project specific or your company specific standards or models or families or anything built into them. But what it does do, it bases the projects upon longitude and latitude, and actual real world, real site, real scale. I like to start there, doing some initial site investigation. Let's just say this is for a 4-story replacement hospital I'm going to talk about, where I can start looking at the weather data from the weather station specific, which is native in FormIt. I can start investigating the vehicular access to the site, where the site is located. I can start to understand this, get a sense of the scale of the neighborhood around the building or the building site, and what the primary points of access are by taking, this is, for example, a Google Earth image that I'll bring into FormIt and set as background, and then start to investigate some site issues around it. One of the other things that we'll do, these are kind of built in FormIt and Sketchbook Pro, and then the great thing is from a mobile work style, I can effectively send these images right from my laptop to the team, and they go right into PowerPoint. We may start to take a look at the zoning envelope and solar exposure on the site from a very early analysis, begin to, as I say, to begin to infer where the building wants to be and what the optimal orientation for the building is. We can start to take that same sort of base diagram and start to take a look at the building in context, opportunities for access, where public spaces and things like that might be around the building. You could also start to take a look at some preliminary ideas for stacking and massing of the building. With the area analysis, with the area tools, basically your surfaces can get output by level. Those levels will basically report your total area within FormIt itself. So this is this is an example of taking a look at 2 different stacks, trying to hit the same target program and staying within the zoning envelope for the project. We can then start to take a look at, for example, what we did here is before grouping, well, even with grouping now, I would still do it the same way, but starting to take a look at that building in an existing context. So building the existing buildings around that building or around your project site, and starting to take a look at what the impact of those buildings are. But what you can see here in this series of slides is I'm doing multiple saving a copy of the file, and within that file, sort of pre-grouping, I would even do the same thing now, saving components of that project in different groups, and then these are all uploading as independent files to 360. This is an example of I just wanted to model the landscape because I want that to come into Revit independently as an object, in a way that I'll show you how we organize some things in the Revit model itself. This image would suggest that I might start to take a look at, do another copy of the file and start to take a look at site influences on the building mass and the footprint, trying to understand, for example, there's a diagram of views to the building and view sheds towards the building through corridors and avenues around existing buildings, understanding how, from an urban point of view, the building is seen and approached from different ways. And then I might save a copy of that and use that in a little more literal architectural fashion to start to take a look at some massing ideas for the building itself. All the while, the RVT file, the AXM file, which is the native FormIt file, is being saved to 360, and the RVT file, it's converting it to an RVT file also at 360. So at this point, after studying, maybe I get to a point where I need to hand off to the rest of the team so I can study other components of the RFP or the interview or another part of the project, and I want the team to bring it into Revit and start drilling down into it a little further. So all those files that you see in the red box are being saved as RVT files to Autodesk 360. I then go on to Autodesk 360 and assign to the team members working on that project. I share those files with them. Everybody gets an email notification. If you're not familiar with it, you basically can share a file, assign whether you want the people you're sharing it with to have view rights or basically a read-only or be able to download them. So I set full permissions for the team. The team has access to those RVT files, which are now on Autodesk 360. One thing we would do to, like I said, to help organize, and the reason why I set all those things up on separate files is the team then can initiate a Revit model so that it has the same exact geographic coordinates and location as the longitude and latitude based FormIt model, right? So that if the team decides to push information back to 360 from the Revit model as an SAT file, which I'll go through in a little bit, I can, what I call, round trip that back into the FormIt model and have updated information or new, another version or a design study loaded back into the correct location in the FormIt model that I can then study or modify and take a look at. So I would have the team set up a series of work sets, and I, because I've been doing this for a while, I still use work sets a little bit like layers. I know that's not the best thing to say, but I still do it. And we would set up a series of work sets that the team could bring in and effectively isolate the objects or the groups and masses that we just created in the FormIt model. And this is how the team would set that up. And this is the sort of final result of that. When they bring the models in to the Revit model, you have a composite of now editable geometry within Revit itself that you can then, the team then, for example, could take and start doing solar analysis on within Revit to start to get an understanding of how the solar footprint, for example, on the right of the existing tower buildings affect or create shadow on the existing new building, helping to lend itself to an idea about where fenestration or shading devices need to be on that building. Sort of exhaustive shadow study for solar footprint analysis or shadow footprint analysis, like the diagrams in the middle. Another example, I'm going to switch gears a little bit. Another example is, again, starting the model off in FormIt where I may have an address and a PDF of, say, an existing floor plan. We're taking a look at this building. We want to do this very quick, very rapidly. It's maybe myself. This is an example of a project that's maybe just myself and one other team member, where that team member is working predominantly in Revit to develop the model. Not that are their only not that that's a person's only tools. They may also be using, Photoshop and Illustrator and all those things. But essentially, they're based at a location in an office. I may be on the road and have, for example, just an existing floor plan and an address of a building that we want to start studying, and we may have only this project, for example, we had about a week to take a look at some design options for the exterior of the building. So might start the model, create the location, build some existing context, and basically just mass up so I have a placeholder, or like a dummy, like a rig object for the existing building conditions. I would then share that model right away. So I would set up the location, I would get my Google Earth image underneath it, build a little bit of an existing context, and mass up the building, and then share that model right away. So that while I'm studying some design ideas or I'm continuing to work on that, the team's now set up the Revit model and built with Revit components a little bit more accurately that existing building. And because of that shared longitude and latitude, or because we set the project up in FormIt again, the file comes in exactly at the right location back into the FormIt model. So this is this is an example of us round tripping that existing model as a mass into Revit using 360 to kind of share that information, and then back into the FormIt model so that you may have a better understanding from working in the FormIt model of where certain floor-to-floor heights are, or where the windows and the fenestration of the existing building may be. I may use that then and switch like totally into analog mode, for example, in this project, and do a series of hand sketches and provide that information back to the team, where the team's then taking that and developing a Revit model that has a significant level of detail greater than, say, my hand sketch, and these would be to do area analysis comparisons for different facade studies on the building.
Does the round trip, does the model, like when you go back into FormIt with a Revit model that's then developed the ways, do you have to do a lot of cleanup going back, or does it let your I'm not sure.
The question is, when you bring geometry, for everyone, I'm going to clarify the question. The question was, when you round trip the model and components back in from Revit, does it bog down the model, or do you have to do cleaning up? And the answer is, it depends on how you build it in Revit. So a window, for example, which is made up of more components than just a conceptual mass, will carry with it more information, which may or may not be usable, which is why in the early conceptual stages of a project, they want to stick to methods of modeling that communicate your ideas that also are conscious of the amount of components that you have in these things. But however, there are tools that are built into FormIt now which allow you, for example, to bring families, your Revit families in, and there's a converter, that basically round trips them back the other way, back into Revit in the location that they're in, that you place them in FormIt. So I think that the FormIt team at Autodesk is working on those efficiencies and keeping information intact and trying to also manage the amount of information and the size or the file sizes. There's also some features which I'll refer to, and Tobias will clarify a little bit later. He'll talk about it, but there's like a purge function that may start to happen that'll allow you to clean up your FormIt model as well. So at that point, while the team is doing some facade studies, I may be switching gears because it's always like a divide and conquer approach. It's never really a handoff approach in the design process. There's a lot of things happening at once. So I may be drilling in and getting information back in the FormIt model about developable area for the floor plate, and working with the teams to maybe do test fits and get an idea of what we can fit inside of this building on the floor, while at the same time further analysis and development of the building could be happening in FormIt, back into Revit itself, calculating areas of materials for build quantity and those types of things. Developing the model to a certain point and level of detail where that eventually is being translated now into presentation level graphics and information using a series of techniques, and then eventually that information gets translated to rendering software where you can have presentation style graphics and a higher level of information that's provided, all generated basically from starting in FormIt. One thing I'm going to talk about now is daylighting analysis very briefly. I'm going to kind of move through this, and this will show both I'm going to expand on this a little bit further and sort of in a segment in a minute, but I want to go through a process of working through geometric manipulation in both Revit and FormIt to try to get what I'll call inferred analysis of, analysis to the point where you can make decisions about how to, because of the graphic tools that are provided to be able to move forward and make accurate decisions in a project. So, for example, we may start out again understanding where the building site is, access to the building and its orientation on the site, using Sketchbook Pro to do some ideas to create some presentation graphics maybe early on to understand where the building vantage points are, and looking at a Google Street View image and then sketching on top of it. Developing the building site area, understanding the available footprint and the total area to build the building on in its existing context. And one thing I love FormIt for is building existing context, because I always like to say, unless you're physically connecting to that existing building, which you might need to know at a later stage in the project, to get context, there's almost nothing faster than FormIt. It's accurate. You have accurate building heights. But for example, what I'll do is I'll go down a street view in Google Earth, and I'll just say, okay, all these 3-story buildings with a parapet are 38 feet tall. All these 4-story buildings are 52 feet tall, because it's relative in some ways. The existing context doesn't need to be accurate to the actual size of the building sometimes, and you can fly through it. I think I built all that existing context in a matter of an hour on the site, which sometimes takes a little bit longer in other software. We may then start massing up the building to get an understanding of the envelope, the zoning envelope of the building, and then that gets translated into the Revit model, where we may begin to develop, understand the building from a solar orientation point of view, and this is the section that's cut through the Revit model, cleaned up a little bit, trying to understand that, and then bring that, once the project has been worked on to develop sort of formal language, bring that back from Revit into FormIt to start to understand the surfaces, manipulating those surfaces, pushing and pulling things, creating some setbacks to try to understand the solar effect, and then again bringing that back into Revit and doing deeper analysis at multiple times during the day. So we're doing some initial analysis in FormIt and simultaneously doing that in Revit, starting to understand that the exterior wall of this building, the geometry of the exterior wall of the building, and how that affects solar gain, so you're not just relying on the glass of the building, which I'll touch on in a minute. There's a rendering of that building which shows the three-dimensional nature of that wall, how it's used to basically shade itself. And what you can see, this is a view of the interior space. And we wanted to get an understanding of what happens is the basic glass material in Revit, when you populate a curtain system, has very little to no parameters of glass. So what happens is when you run the illuminance analysis, which is also done in 360 through the rendering function, you can see the surface areas are very hot. That's because the glass really has no properties. Working with Guardian on this project, Guardian provide us access to, there's some basic access that they have that everyone can use their solar analysis tools. Their performance calculator allows you to pick any manufacturer's coatings and build the actual compositions of your glass and provide the actual coatings. It's almost a click of a button. It's not really. They have someone building them. But if you then submit, you're able to save your project, save the compositions of your IGUs, and you're able to hit a submit button, and they will build you a Revit model that has these RGB values, which help, in a way, translate the illuminance diagram, the illuminance calculation into actually shading properties of the glass, of the different coatings of the glass. It'll build a Revit model for you that you can populate back into your curtain wall family. You can see here's some analysis that's run that same exact image from default glass material to calculated glass material that starts to give you the impression of how that works. And then because of that geometry, while we're working back and forth between the FormIt model, using these sort of high-level tools as the performance calculator, using illuminance, which is on the 360 rendering website, rendering your model in the cloud as an illuminance diagram, keeping that information accurate and moving forward. The team's still doing working documents and drilling down into the specific geometry of that facade, developing the model so that there's geometry keys within the documentation that also control the geometry of the glass, so that as the analysis is being refined, the geometry of the building is also being refined from a working model point of view, and then punching that out into into level of detail for constructability and sharing that with the rest of your team. And then finally, the final results of that are a visualization and ultimately the building that's drilled down to a level of accuracy where, again, the process went from studying some initial formal geometry in FormIt to really diving into some other tools and tying them together with the Guardian tools, with the Autodesk tools, and keeping that information relevant with the production, the production side of the team, moving the project forward. One other thing, and I have this in here, I'll buzz through this real quick because I want to be conscious of time. Another thing that FormIt's really good for is some initial studies where you have things which are highly repetitive, the grouping function, being able to do studies for buildings that have multiple stories, highly repetitive in nature, a level of detail that you can adjust. And now with the, I'm going to buzz through this here, but I'm going to talk about one other project that kind of ties a little bit of this together and talk about some site analysis and some of the, I'll do a couple of the workflows on how you get topography from the Revit model into FormIt. And I'm going to give an example of how to do it successfully using some other tools, some other software, and some early concept level ways of doing it as well. So you may have a project where, again, you're doing site analysis. This is all done in Sketchbook Pro with Sketch and with all on the iPad. So a whole series of mobile tools that you can do very quickly to get you to images of a high quality that you might use in a presentation. Starting to understand the existing site, which is right next to where that blue dot is. This site in particular is very topographical. It sits on top of a mountain, and we have about a 70-foot elevational change across the site. So understanding the building, so when we start the FormIt model, understanding that there's some elevational changes that are going to happen and be important about this project. One of the things that I like to do, I showed this at RTC, is when I start the FormIt model, I build a compass. I usually start with the compass and like a solar dial, and I'll do some early analysis before even looking at what the building is to start to understand what the optimum solar orientation for the site is. Okay, understanding that there's really no existing buildings around this project to cast shadow onto the building. They're basically at the top of the hill in the woods. So I'll build a solar compass to start to do some analysis. The team, meanwhile, may take some of that information and provide some data for me back and forth, creating graphics. That solar analysis, I may start to, like, literally the orange is me physically creating masses, which are the solar incidences across the site over a day and time, so that I can actually have geometry to snap to. I use it like rig geometry, so I'll build that and group that. And that might be a starting point for me to build and snap to and become a host for building studies. Starting to do the solar analysis right within FormIt to understand different times of the day, and a curved facade is ideal for that, which is why I do the solar dome on the cylinder, so you can understand the orientation, optimize that, understand where your ambient zones are over the course of the day, and try to dial into the location of the building. This is sort of an example, an exhaustive example of March, June, and December, which are the equinoxes and solstices are the only days that I actually use most of the time, unless I have to adjust for climate difference. Like I might adjust the solar days based upon if the project is in the Northeast, or if that area gets more annual snowfall, I might adjust a little bit. But the basic diagram I study is March, December, and June. With this project, we want to study where the building was located, because I said the project is very topographical. So I might start to do some hand sketches and work with the planning team to understand building massing and stacking as it relates to the site and try to optimize exposure of the building. We might use FormIt to understand ideas for expansion on the project, help a client with feasibility. This is looking at the idea of what if we had a third story onto the building. And also within that, trying to optimize the building form using the conceptual form tools within FormIt itself, getting an understanding of how a building in different orientations and different stackings would perform. So before we even get to understanding the building on the site, we're doing a sort of abstract analysis, sort of devoid of site, to try to get an understanding of the building and then begin to marry that with the site. And again, our team, we use tools such as smartboards and things like that, or we will host a GoToMeeting where I will pull up images on the iPad and share the screen, and we'll use it as a whiteboard and sketch right on top of them, so that the team is sort of has this live interactive experience during the design process. Once we have sort of an understanding of the site, we may have that built in the Revit model and start to do a series of diagrams which talk about maybe the cut and fill on the site and how you displace the landscape and the geometry around the site to create site buffers, understanding sort of location of the building very early on in the conceptual process. Meanwhile, at the same time, so that maybe devoid of the site, sketches are happening in FormIt to start to get an understanding of how the building mass might fit into the site, where the roadways are, the language of the building as it sits, so this two-story configuration. And then doing some early solar analysis to start to understand maybe projections around the building, how they can be used as shading devices, and sort of getting to a point where you have a conceptual model that you then want to hand off. So then sharing that model through 360, the team can then bring that in to Revit and begin to organize that with the site and the topography in the Revit model, and literally use the masses that come in from the FormIt model to select those surfaces and create curtain systems right in Revit. So it's a very quick way to translate that information and maintain the integrity of the geometry. Again, then back in Revit, so in FormIt, maybe in parallel, I'm starting to take a look at the site. Again, I don't have the topography back into the FormIt model. I explain how this site has a 70-foot elevational change, but I'm starting to take a look at things now like superimposing onto that abstract information of sort of the solar position, what the setbacks and what the easements are around the site. The team, meanwhile, in Revit in this project has built all the existing context buildings, which they've shared the link through 360 as an SAT file, and I'm able to pull those into the FormIt model and group them, so I can easily change material or just make a quick way for me to sort of enable and disable them. One of the first ways we started to take a look at how to get geometry into FormIt, and we wanted to keep it white at first. So we came up with this crazy idea of, what you see, 1,000 reference planes and a section every 5 feet, and had the team build literally a conceptual mass that essentially lofted between section cuts through the topography model that they built. We then built that entire surface as conceptual masses, and then through 360, we were able to bring that back in to the FormIt model. We were able to import that back into the FormIt model and effectively get that same geometry. One of the cool things about this that we liked is it was non-triangulated, which is the way we made it. And I was able to superimpose that with the model that we had made. It came into the correct location and elevation now with the site analysis that we were doing back in FormIt. So we have this sort of parallel track of the team working very diligently in Revit, the team working in FormIt, and how you can combine the both of those synthetically to get the most amount of information, share information about the project. One of the great things about that is because it came in groups and as a surface, you're also able to edit it. So I was able to not only change the material, but you can set your work plane now. So if I wanted to build something off of one of those sloping surfaces of the topography as a reference, we could, and it sort of superimposes that information. Meanwhile, again, to go analog again, I may be doing a series of what you see hand sketches, or in the upper right-hand corner, taking the FormIt model and creating a surface and using that to subdivide the surface with lines and sort of draw right on that surface to send that back to the team and do a series of sketches about, in the lower left, maybe an idea about the roof of the building. This is that subdivided surface in FormIt, which I gave an extrusion to, and I was able to basically draw on and copy and do a sketch in FormIt to send back to the team to help them define where the roadways and the parking lots were on the site. Then superimposing that early concept model that I had in FormIt, which, by the way, was done completely without scale, so I had to bring it in. We scaled it in this instance up to the size of an object and then located it correctly on the site. And now I basically have that initial model back into my topography, right? So it seems a long way, seems like a long way to get there, and I'm going to go through a better way to do it in a minute. This, to back out a little bit, and I said we were going to talk a little nonlinear nature, is while the team might be working on one part of the project, I might be back into basic building mass, starting to study solar analysis around the actual form of the building as it sits on the site. In this case, we have a building at the bent bar that sits on the site, which then enables you to take this geometry, it gets sent back into Revit, and the team can start to work on some design ideas and massing for the building in the Revit model itself, which is translated here in a little bit further detail. This is actually in Revit in the situation, and using some of the exploded views to take a look at that building. Meanwhile, getting that back, or a version of it, round tripping that back to the FormIt model, where I can start to take a look at very quickly shading and some solar analysis on that building mass while the team is working at a different level of detail. Back in Revit, the team's cutting sections, starting to understand the building from a zoning point of view, and from developing sections that we can then translate and share with the rest of the team. Back in FormIt, looking at other ideas about the building. You know, there's another version of the building. All this is done within FormIt itself. Taking a look at different ideas for fenestration, applying materials, starting to get an understanding of potentially shading devices on the exterior of that building and how different versions of that sort of shading system affect the solar gain on the building, and then taking snapshots of that and maybe sketching on in Sketchbook Pro to communicate ideas back to the team about changes in the fenestration or changes in the geometry of the canopy or things like that. So not necessarily having to model everything to communicate changes necessarily. And the team being able to then take that back into the Revit model and translate it to the level of detail where renderings are starting to happen now and visualization of the ideas is occurring. And meanwhile, working from a survey, we were basically able to develop the complex geometry of the site. So I'm going to take you, the last thing I'm going to do here is spend 5 minutes or so and take you through this workflow of how we get topography, accurate topography from a survey that's built in Revit with using pad sites and using points on the topographical surfaces in Revit, not a conceptual mass, but the actual site tools in Revit, and getting that back into FormIt and combining it with the building. So what you see here, we created the geometry, we created the pad sites of the building, and we created all the roadways and parking around the site. We then create a view where we isolate that geometry, right, in the view, and this will be our view where we export. We then, from that point, we're about to export the DWG, the DXF file. One of the things to note is make sure you set it to the ACIS solids in your modify settings. You don't want to export it as polymesh. I'll explain why. We then, everything in that view now is ready to get exported, and we open it in our in Rhino. This is Rhino environment, which you see now. So we've successfully exported that DXF file and changed it to ACIS solids. We've launched Rhino, and one of the first things to do is, now remember, we've already gone through the process because we've started the project in FormIt. Our locations are the same in the FormIt and the Revit model, and this is one of the things that you have to go through in Rhino to make sure that the translation out of Rhino maintains that same location integrity. So make sure that your model units in Rhino are set to feet if that's what you're working in. Obviously, if you're working in metric, make sure it's set to metric. But we were working in feet and inches, so we made sure our Rhino model was set to feet. We then select that file, the DWG that we created out of Revit. That's that file right there. So we're about to import that now into the Rhino environment. And when we do that, we make sure that we have it set to inches on import, okay? So we set automatic for the mesh precision, and we set our model units to inches now on import, and voila, we get the entire model brought in as a DWG, as a series of triangulated, effectively ACISs into Rhino environment itself. The next step in Rhino is what we've tested was there's a bunch of information that gets brought through in the translation and the writing of the file out to DWG and bring it in that we needed to clean up. And we found we're able to keep our file sizes down that way. So we basically have gone through a process of optimizing that Rhino model. The first step is to select all the curves, and you can delete them because you won't need the curves because the geometry is there. The next thing we do is we go through a process of drilling down into the reduced mesh as your command in Rhino, which will allow you with this slider to basically drill in and adjust your tessellation and geometry to get it to the desired polygon size, which polygon size translates to file size, if you will. So we're able to reduce it, and we're looking at maybe reducing it down to like 75% of what it comes in. You can go a little bit more, but you start to get some loss in the accuracy of the geometry. It'll just make the triangulation larger the further you reduce it. And then once we've drilled that down, we go through the mesh to NURBS conversion, and we convert all the meshes into NURB poly surfaces. And this is the critical step that allows us to translate that back to an SAT file. Once that happens, once we've converted, there's a little bit of overlapping surfaces, so you can delete all those overlapping surfaces. So that final step. Once that step happens, you're going to export as an SAT back out of Rhino. Okay, so your ACIS export happening back out of Rhino now that you've gone through that three-step cleanup process. Once that's there, we found that once you share the files on 360, we just update this file. So if we find that we need to add a retaining wall to add more parking, or change the geometry of a roadway, or delete a section, or increase the building footprint, which changes the building pad, you don't need to keep sharing the files. Once you do that, we establish a file name from the beginning on 360 and translate that information out. So all the team has to do is literally update the files on the 360 site and inform the person that's using FormIt, sorry, getting all my programs confused, that the model's been updated. You can see when that's been updated. So then I can go back into my FormIt model, which you can see just has an image of a site plan underneath it, and that's what I was working off of. Basically, it's a placeholder, and I have some basic geometry of site from a conceptual level that I may have designed in the FormIt model, but I don't have any real site geometry in here yet. I can then use the import 3D models. I can pick that same file, 300 new location streets, for example, is what we keep calling our street model, and I can import that. It's about 27 meg, and over LTE, it takes about a minute and 10 seconds to bring something like that in. And you can see that triangulated geometry comes in at the correct location from the Rhino model now. So we went FormIt to Revit to Rhino, back into FormIt again to create some geometry. And that's bringing in the actual site. We can change the materials of them because the meshes are selectable, and you can change all that geometry. You can actually work right off of that geometry. You can modify that geometry. You can delete it, and you can change the materials and effectively get geometry which is in the correct location and is exactly basically your topography that you created in Revit. And then, again, how that then translates down to a level of detail that you can use in presentation and create some representative graphics of the building. So with that, that is a wrap up, and I will stop talking. We have about 7 minutes left if we want to have some open discussion, or for anybody who wants me to go back to anything. So thank you.